first one, just a review. Find the zeros and write it as a linear factorization. So the first thing you're going to do is graph. Oh, well, you can do P over Q if you want, but if you have a calculator, use the calculator. So from the graph, you can see that x is equal to -2, 1, and 4. From here, you just need to do synthetic division and then take it out. -2, 1, -3, -5, 5, -6, 8. And then just do synthetic. Okay, so make sure you take each one of them out. And then the last one. All right, at this time, you can see that the constant is going to be 1. The next number is 0, that's x, and then x squared. So this is just x squared plus 1 equals to 0. So x squared is equal to -1, which means x is plus minus I. Okay, so the zeros are the 3 you found and plus minus I. So writing them as a linear factorization, that is x plus 2, x minus 1, x minus 4, x minus I, and x plus I. So 5 zeros. Okay, so if you couldn't get it to this, make sure you kind of do more practice on, when you're doing homework. Make sure you pay attention to how you're doing it and then review your notes. All right, what if the problem only gives us complex roots? So just like the warm-up, if they tell you that there is a complex root, meaning that this number will make the equation equal to 0, then if 1 minus 2i is a root, then what else is a root? 1 plus 2i. And then we kind of talked about that in the warm-up, that we could do synthetic division and divide it out, but we're going to have too many chances to make mistakes. So we're going to actually make it into a factor. And then multiply together and then divide it out. So this question has 3 roots. From the complex numbers, you already found 2 roots. So you just need that one last one. So go ahead and figure out the answer and then write it as a linear factorization. Okay, so the first one, if you have not gotten the answer, x equals 1 plus minus 2i and 3 for the zeros. So linear factorization, make sure you keep the x in there. So this, and then an x minus 3. So if you have not, move on to the next one, move on to the next one. Same thing, so find the zeros and the linear factorization. Okay, so the roots should be, or the zeros should be 1 plus minus I. And once you do the long division, you're going to get a factor that's x squared minus 3. So then you have a plus minus square root 3. The linear factorization is x minus 1 minus I times x minus 1 plus I times x minus square root 3 times x plus square root 3. Good? Okay. The last thing we're going to do is this thing called irreducible quadratic factor. What's a quadratic thing? How many degrees? 2. Okay, so we're going to leave it as irreducible. Irreducible means that you cannot reduce or you cannot factor. Basically means that if you do try to factor it, you're going to have imaginary solution. So basically, if you get to a point where you cannot factor anymore, if you try to factor, you're going to get imaginary solution. They want you to stop. So for example, something that's going to yield imaginary solution from a quadratic factor would be something like x squared plus 1. X squared plus 1, if I try to factor or if I try to find a root, I am going to have plus minus I, right? So that's not factorable. Or maybe something like this, x squared plus x plus 1. Can I factor that? Can I factor that? No, I cannot factor that. If I try to factor that, I will get to, let's see, I think this is going to be imaginary as well. But basically, if you get to a point where you cannot factor anymore, it's going to give you imaginary solution or even square root solutions. They just wanted you to leave it alone. So, for example, this one. They say they want you to write this as a product of linear and irreducible quadratic factor. So once you get to a point you cannot factor anymore, they want you to stop. So let's look at it and say, can we factor this? Does not look like it. We can try P over Q, or we can use our calculator to figure out where the first root is. So go ahead and try that. Okay, so it looks like 2 is the root, so what you're going to do is just synthetic division. Okay, you're going to get to this point, x squared plus x plus 1. Can you factor this? No, because that was the example we had, right? So you cannot factor this. They just want you to write it as a product of the one you found and the part that you cannot factor. So basically the answer is x minus 2 and then this irreducible quadratic factor. That's it. Okay, so you want to make sure you read the question and get to a point that they actually tell you to stop. So this one, once you get to the irreducible quadratic factor, you stop. If it wants you to write it as a linear factorization, then you will have to keep going.